Experiment. That's a type of research. It's a fairly rare type of research. An experiment has a power to it. Not a magical power, but a statistical power. And you can draw conclusions from it that imply causality. Most of the studies we have in the domain of psychology give some suggestions as to what might cause one thing or another, but they can't reach a conclusion on that because they aren't experiments. Correlational studies, for example, all the stuff you see on Stona where you're filling out all these surveys and people are getting some operationally defined variables out of that. All right, if I see one thing goes up and another thing goes down, I go, oh, this must cause that. Maybe, maybe not. And that's important to realize. But if I have an experiment, then what I'm doing is manipulating a variable in a systematic way under controlled conditions. I'm observing to see whether any corresponding changes are occurring in at least one or more other variables. So an experiment gives me the gold standard of understanding causality depending on how it's run. I want to run it as an independent variable. I got to have a variable that I can manipulate, one that I can change myself as a researcher or have some effect on in a systematic way. And then if I am able to do that under controlled circumstances, meaning I'm taking account of all these other factors that might actually produce this effect, and I can rule them out, then if the independent variable has an effect, I'll see it in the dependent variable, assuming they're related, which I would be assuming. The nice thing about experiments is it gives you a really good underlying foundation to draw conclusions that say, well, this caused that. All the other variables were taken care of. All the other variables were controlled for. You can't control for all the variables anyway. We'll give some examples of that in just a minute. But to the degree that I can control them, then if I manipulate the independent variable and I see a systematic change in the dependent variable, I can make the conclusion that the independent variable affects in a causal way the dependent variable. Everybody on board with that, I think. Now, who am I going to be working with? I got a population. I got a population of interest. Now, the population of the planet is huge. And the experiences we have as people change over times, right? We don't experience the world the same way people in the 1920s experienced it, or the people in the 1820s, or the 020s, or the 20s BCE. People find themselves in circumstances and they change in response to the circumstances because we're adaptive. If I'm interested in studying anything, whatever it may be, if it's aggression or self-esteem or caffeine's effect on memory or whatever you want to study, I got to figure out, well, who am I trying to find this information out about? Right? Am I looking at toddlers and preschoolers? That tells me that's my population. I'm not looking at whether or not adults push each other in preschool because they're not in preschool. So I would define them as outside my population of interest. So when we talk about population, we're really talking about of interest to the researcher pertaining to the research being conducted. And I have to try to get a sample. It would be ideal if I could do random sampling. If I could take anybody at random and put them into my experiment. If I could take anybody at random and put them into my experiment, then everybody has an equal chance of being in my experiment. That means if there's some personal variables that might affect its outcome, that should wash out, right? If being male or being female affects the outcome of my experience and I've got an equal mix, because random draw would say I would have an equal mix, well then that should be washed out, right? If being older or being younger affects it and I've got a random sample, that'll be washed out. If some kind of ethnicity or race or socioeconomic status or educational level or political preference or religious ideology or whatever it may be, family role, well, I should have almost one of all of those in there if it's a truly random sample, and so all of that should wash out, but I can't get that. I can't get a random sample. Because I can't just tell you to be in my research. It would be unethical to do that. So what I got to settle for is the sample I get, and then I want to randomly assign them to groups. Therefore, I got a subpopulation, whatever amount of group people I can get together willing to be in my experiment, right? I put them in my study. I want to randomly assign them to groups because of the same reason. What if I was doing a study at 8 in the morning and a study, the same type of study I was doing at 5 in the afternoon? If I just let people choose themselves whether to show up at 8 and whether to show up at 5, you'll get early morning people here, and they're different than non-early morning people. Anybody here early morning people? Get up real early? Yeah. My dad's one of those. He's up at like 5:30 in the morning, man. That seems insane to me. I might go to bed at 5:30, but I am never getting up at 5:30 if I can avoid it, right? I'll do it if I have to. So I'm not a morning person. And you put me in an 8 a.m. slot, right? That's going to affect the way I perform on a study. So what I want to do is be able to randomize early morning people, mid-morning people, late morning people into any given slot so that I wipe out the effect of whether you're that kind of person or not that kind of person, right? That way I'm getting more at the actual independent variable because some of everybody should be represented in my random assignment. Where am I assigning them to? Well, I've got an experimental group. The experimental group is going to receive some level of the treatment. Maybe I'm trying to boost math scores and I have some kind of tutoring program, right? Maybe I have some kind of online interactive software that I want to see if it's effective or not, right? I want to see what the treatment is. Maybe it's a medical treatment. Maybe it's a level of a drug, chemotherapy, radiation, you name it. Whatever it is, we want to see that it has an effect before we start using it on just everybody. So under controlled conditions and ethical circumstances, we might move ourselves into human trials, but we need to have an experimental group that ideally gets different levels of treatment so we can see how it functions at different levels or whether it functions at all. And one way we'll be able to know that is by comparing it to the control group. It's a little dry, I know. But follow with me a little bit longer and I'll make it more fun next time. And it should be very relevant at all times. Y'all have a good day and I'll see you on Wednesday. I can't make assumptions about where everybody is on knowledge. Some people had lots of scientific training in high school or have had it since they've arrived at college, and other people not so much. So the things you should know for your test are in white font or indented under white font. And somebody came up to me before class and said, man, I'm writing all this stuff. It's hard to keep up. Exactly. So that's why I'm going to draw your attention to test material. When you get to white font, you should be writing. Don't be highlighting what I've given you in my notes. You already got that. You could go back and highlight it, but write down the examples that I'm giving you. Write down the thoughts that come to mind, especially if you can think of applications in your own life. Jot those down. It'll help you to remember the information. So we went over why you got to, settle for random assignment, because you can't truly get a random sample. You get the sample you get. And then you get to assign them, assuming you're doing an experiment, into different kinds of groups. Well, you got a treatment group or an experimental group, and that's going to get some level of your independent variable. And then how are you going to compare that? You could compare it at various levels of the independent variable, but you want to control for things like placebo effect, for example. You want to prevent researcher bias if you can, because you might have researchers acting in such a way as to influence their participants, assuming we're talking about human participants, right? So you want to control for that with double-blind studies if you can do it. But who are you going to compare it to? You want to compare it to people who don't get any of the independent variable, but they have to think that they're getting it, because placebo effect is real. People really do get better on physiological issues because they believe they're going to get better. That's why doctors used to give out sugar pills, because people believed that the doctor knew what the doctor was talking about. The doctor said you're going to get better. The doctor would suspect it might be a psychosomatic issue, meaning that you're stressing or you're having some kind of issues with coping, and that's manifesting physiologically. Maybe it's stomach aches or headaches or fatigue or whatever it may be, listlessness. But having that doctor arrive on the scene and say, this is going to help you, for those who believed it would, it oftentimes did. And there's placebo effect not just on mental health, but also on physical health. That's why anytime you are looking at demonstrating the effect of a drug or any kind of treatment, you have to have an effect that's better than placebo, right? If it ain't any better than placebo, then it's nothing. So you got to figure out what would it be if people got nothing. And you got to do that ethically, because in the cases where people might have diseases and some treatment might benefit them, right? You might put them on a waitlist control where they get the real treatment later, assuming it's efficacious, meaning that it works, right? Because you don't want to prevent them from having it. So ethics being accounted for, I want people to believe they're getting the treatment. If they know that they're in the control group, then I won't get any kind of effect. I want to get the effect of them thinking they got a treatment, right? And so I give you this example. Let's see here. Flip over to the dot cam, which it's not very illuminated today. I don't know why that is, but usually it's a lot brighter than this. But I just give you this example. So I'm going to design me a study to see the effects of caffeine use on memory, right? This is my hypothetical study. This is not real data, but it's to illustrate independent variable, dependent variable, treatment group, control group, random assignment, and why you should look at this at all. So I've got my independent variable. It's the one I can manipulate, right? That's the one I can change. So I got a control group that's going to get 0 milligrams of caffeine, and then I got experimental groups or treatment groups that are going to get some other actual level of the treatment, which in this case is ingestion of caffeine. But you know how caffeine works, right? People use it differently, don't they? Some people use a lot of it, and it doesn't seem to affect them at all. They're tolerant to the use of caffeine, right? Other people hardly ever use it, or they're sensitive to it, and only a little bit really works them up. And so you can see how if I don't randomly assign my subjects or participants to the groups, I might accidentally just have a bunch of people who are overly sensitive to caffeine in one group, such that the effect I see is not really based on the level of the treatment, but based on the kind of people who are in my group, right? Some people have different weights. They have different elements, whether they slept last night or they didn't sleep last night, whether they've eaten today or whether they're hungry, right? All kinds of things, whether they're motivated to be in the study or they're unmotivated to be in the study. There's all these factors that might affect how they perform on my dependent variable, my DV. So what am I going to measure them on? I'm going to pick some kind of variable that I would think should show some differences if, in fact, this has any effect at all. So I manipulate my independent variable, and I look to see how they recall items on the list. Let's say I give all of my participants items on a list. I say there's 20 items on the list. Read over the list. I give you X amount of time, but it's standardized for everybody. Everybody gets the same amount of time to study the list. And then I maybe delay 2 minutes or 5 minutes, but some standardized period. And I say, now recall as many words as you can on the list. And let's say that in general, people do pretty good on this, and we've tested it out. Now we want to see what the effect of adding caffeine to the situation is. Now, I could give you caffeine in a couple ways. I could have you take some in a drink, right? But then I can't account for the various ways that your bodies might metabolize it, right? Because if you've eaten, that's going to go through the digestive system very differently than if you haven't eaten, and things like that. I could ask you not to consume any caffeine before the study, but I don't know whether you do or you don't, really, unless I take a blood test to verify it. But let's say that I want to get past the idea of eating it. I could have you snort it. But most people are averse to that, right? Snorting powder is kind of nasty, I think. I ain't never done it, but I've seen people do it. Whew. I don't want to do it. So I'm probably not going to have you snort your caffeine. Let's have you inject your caffeine. Let's me be the researcher, and I've got a serum, right? And I'm going to inject it because it goes straight into, let's say I do it intravenously, it goes straight into the blood system. Now I know that everybody gets the same amount, right? We're bypassing the digestive system. We're passing the mucosal lining, right? We're going straight into the blood. So if you're in a control group, you're still going to get a shot. And you don't know what's in that shot. You know that there's some active treatment that the researcher's testing, and that later you're going to have to try to do some kind of a behavior or performance on an outcome measure, a dependent variable, but you don't know what group you're in. So let's say that in the 0 milligram group, the people on average can recall about, I don't know, let's say 75% or so. So that's not bad. They can do pretty good in this group. Well, now I know that having received an injection and all the attending anxiety that might go with getting an injection, right, that could affect you, well, that's going to be the same for everybody. And in terms of tolerance or metabolism or things like that, weight, I've got people randomly assigned, so I should have some of everybody in each of these categories, so that should wipe out some of my individual difference effects. So that's about our baseline. So now we know what to compare our results to. Okay? So now I'm going to have a group that's going to get 50 milligrams. So 50 mg. That's going to be treatment group 1. And let's say that they take their shot and they study their material and they do slightly better. Well, the first question is whether or not that's statistically significantly better, right? Because if it's not statistically significantly better, then it is in essence no different. In other words, I could have gotten those results by pure chance alone, and I shouldn't have a whole lot of faith that that's a real effect. But let's say that that's modestly significantly different. It's p.05. In other words, seems to be a real effect, not due to chance. A slightly enhanced ability to remember things after, taking in caffeine at 50 milligrams over and above what somebody may have used at that point, because we don't know. We don't know about tolerance. We don't know about things like that. But we know that anybody with any issue is just as likely to be in this group as any other group. So it shouldn't be that our sample is biased. Follow? Okay, so now I'm going to have a 200 milligram group. Well, that's about the amount you find in a cup of coffee. And let's say that I see a bit of a spike. I wouldn't expect on average that anybody's going to get 100, but let's say they get up to 90% at 200 milligrams. Well, that seems to be statistically significant. If I had a little bump that reached significance, then a big bump should be all the more significant, and we would see that it was. And we would say, hey, we might be onto something here. So a little bit of caffeine seemed to help a little bit, and more caffeine seemed to help a lot. So what if we give even more caffeine? Let's go ahead and give them 2,000 milligrams. Woo! And we say, they can't remember shit. Well, now we have another finding altogether, because it seemed like we were trending in a direction. You could make the assumption that the trend continues indefinitely, but it doesn't. At some point, you're going to be freaking out, and you won't be able to concentrate on the words, much less recall them. And you see what I'm saying? You need these various groups to be able to differentiate what the effect is of the independent variable upon the dependent variable. Because you look at this and you say, well, gosh, who would do this? And of course, this is hypothetical. Nobody should ethically give anybody 2,000 milligrams of caffeine. You may kill them. Somebody might have a heart attack up in here. But you can see what we got going on here. If I'm a researcher and I believe that caffeine helps people with memory, then I don't want to know which people are in which group. I want a double-blind procedure. So a single-blind procedure means the participant doesn't know what group they're in. The double-blind means I don't know which group they're in. I just get a syringe labeled, now that's all tracked, so it's known at a higher level who's getting what, but the person interacting with the patient doesn't know. So if I give my control group an injection and I had this bias and I knew who was in the control group, I might go, okay, well, don't worry, but do your best, right? And if I had this pre-existing notion that 200 milligrams was going to be really good, I might be like, hey, you're going to take this and I'm sure you're going to do pretty good on that test, right? Which might differentially affect my participants' motivation. And if I get them up in the 2,000 milligram, I might be like, woo-hoo! Be careful now. I might freak them out before I ever give them the injection. Those would be effects that I created as an experimenter that might systematically bias my results. Therefore, I want a control group, I want an experimental group, I want to be able to manipulate my independent variable as cleanly as possible, meaning with as much control as I can muster, and I want to have as objective as possible a dependent variable that I can see how it varies, variable, based on my manipulation of the independent variable. And I don't want my subjects or participants who have been randomly assigned to account for individual differences in these groups to know what groups they're in, and I don't want the researcher administering the treatment to know what groups they're in. That's a tight design, and it might give you some conclusions that you can hang a hat on, right? But then you get into issues of generalizability. Maybe it doesn't generalize to all age groups if I'm studying college students, for example, right? And I would then also want to replicate it. Maybe it's just a function of the way I did this particular test with this particular group. So if I found statistical significance, I could have a little bit more, confidence that it was a real effect, but I'd want to do it again with a whole different sample to see if I can replicate it. If I find it again, I can have even more confidence. If I have somebody else do it over in this area of the country and they find similar results, in that area of the world and they find similar results, I can start to say this seems to generalize. It's not just a sample here or there. It seems that people, on the whole, on average, exhibit these kinds of trends under these circumstances, which gives us some knowledge rather than people's opinions about stuff. And it's through the research process and the peer-reviewed dissemination of that research that we start to assimilate and understand very complicated phenomena, right? That's what I want to be your take-home message.